DAX is the formula language commonly used in Microsoft Power BI to create custom tables, measures, and calculated columns. Once you understand and master DAX, it gives you a powerful control over your visuals, reports, allowing for better performance and flexibility within your Power BI report and eventually your Power BI dashboard. So welcome back to Excel Island, where the objective is to learn and master the Microsoft Power BI tool over the next 100 days. And today is day 42. We've been so consistent learning over the past 41 days. You can catch previous lessons and live stream on the live stream tab on the channel. And do well to support the channel by hitting the subscribe button. So we started a course a few days ago, I think 2 days ago, that is on day 40 or day 39 if I'm not mistaken, which is DAX functions in Power BI, which we're actually learning all about the DAX function in Power BI. And so far, we've covered setting up data model with DAX. We've also covered DAX and measure, that is creating custom functions to create calculated measures. On today's live stream, we'll be learning all about the filtering and counting function with DAX, which are the filter functions contained in DAX, like the count A, count rows, count distinct, and count blanks, and so on. So this focuses on counting functions. This live stream will be focusing on commonly used DAX counting functions or filter functions. So also all data set exercise files, Power BI files that we'll be using so far over the last 41 days is already linked under the YouTube description. So do make sure to download those files and practice along with me. You definitely have to practice. There's no two-way or there's no other way around it. You have to practice and get your hands dirty. So without further ado, let's jump back to learning and welcome back to day 42, where I try to learn more about the filter functions in the DAX language. So I'll just head back to the DataCamp platform. This is the platform I'll be using for the past 41 days to learn and master Power BI. When I started this live streaming journey, this new habit of this way of learning, or this habitual way or habit of learning, I started with the data analysis in SQL character, and that ran for over 100 days, where we did a lot of learning. So you can catch those previous live stream on the channel also. Then we started with the data analysis in Power BI character, which we are at least 50%, we're over 50% in the whole character, and today is day 42. That means we are not lagging behind, definitely moving forward at a better or faster rate. So definitely after completing this data analysis in Power BI, the next objective, the next challenge we'll be going for another 100 days is the data analysis with Python. As a data analyst, you have to upskill yourself in tools so that you can become relevant and keep getting gigs and jobs within the data industry. So we are definitely learning data analysis with Python this year also. So these are the goals. These are my goals for the year. Data analysis in SQL, Power BI, Python, and Excel. Of course, I learn Excel behind the scene almost every day. So currently, probably in the future, we start taking it to data engineering, data science. We don't know yet, but let's see what we can achieve with this. So I'll just continue with the data analysis in Power BI career track, which contains 70 courses estimated for over 48 hours. And we've covered quite a lot of courses. So if you can see, from introduction to Power BI, we did some case study, which is to get our hands dirty rather than just learning. We did some more courses, then we did another case study here. So you can catch all of this on the channel. So do well to catch up on them. So we just continue from the DAX functions in Power BI part that we are. I think we're on the third chapter, if I'm not mistaken, which is filtering and counting with DAX. So let's continue from the third chapter. Okay, so I'll just put on my headset.
Welcome back. I'm Maarten and the second instructor for this course. In this chapter, we'll discuss some more examples of DAX measures in Power BI. We'll start with filtering and counting functions. In the previous chapter, you've seen that on top of row and query context, filters are applied on the filter context. This means that filters take precedence over any slicer of visuals on your dashboard. Therefore, filter functions are great for situations where you need visuals that aren't affected by the query context. Let's show with an example. Suppose you're creating a report with lots of slices and visuals that interact, but you always want to show the total sales value on a summary card that is not affected by any selection. The usual way of calculating the total sales measure would be by taking the sum. However, a selection made with a region slicer would impact the total sales value, which we want to avoid in this case. This is where the calculate function comes into play. Calculate allows you to evaluate an expression within 1, 2 or more filter contexts. It is often used with intermediate functions, such as the all function, which ignores any filters that might have been applied. As a result, a region or any other slicer won't affect our calculation, which is what we want for our summary card in this case. You'll see an example in the exercises. In addition to all, there are two other common filter functions that we'll discuss. The first one is filter, which returns a table that represents a filtered version of your target table. Let's say, for example, that we want to filter the orders to show only the sales for a certain salesperson, Chuck. We can use the filter function within the calculate function to filter the fact table, to only include values of the related dimensional table for the salesperson, Chuck. Since the filter context always precedes the query context, the filter function allows you to set a value on a visual. Note that the related function is used to return values from the salesperson column of the sales dimension. The final common function to discuss is cross-filter, which is a relationship function that can also be used in a filter context. Cross-filter specifies the cross-filtering direction to be used in a calculation. In this example, a single direction relationship is defined between two tables. Cross-filter can override this by setting the direction to both for a particular measure you want to calculate. So, what are the main benefits of filtering in DAX? The first reason is that it can improve performance by eliminating unnecessary data for a specific calculated measure or by defining specific relationships between tables. Secondly, it allows for easy reusability of measures, since you can refer to other measures in a calculated measure. Lastly, it helps when specifying complex calculations by using a concise syntax instead of separate measures and several lines of code. Another common set of functions are the counting functions. It comes in different flavors, but here are the most used ones. The normal count function is great for counting non-blank rows that consist of numbers, dates, and strings. Count A is similar to count, but it also counts Boolean values, such as true or false. To count the number of blank rows, you can use the countBlanks function, and if you want the number of distinct values in a column, use the distinct_count function. Finally, to return the number of rows that don't have blank values in an entire table, the countRows function is used, which takes a table as argument. Let's see whether you filtered out the essentials of this lesson.
So we got introduced to calculates, then combination of calculates with all, which allows to return no filter when you use the calculate with the all function. They also talk about cost filtering. I think also they also mentioned different counts. Yeah, that's cost filtering, which is used for directional relationship or filtering between two tables. That is cost filter. So cost filter. Then we talk about the filter function itself. Then we also talk about counts, count aids, count blanks, distinct count, and count rows. So that's why it's interesting. So many filter functions there. So understanding different filter functions. So filter functions are one of the most powerful features of DAX that allow users to perform complex analytical operations with a minimal amount of DAX. So understanding the power of these filter functions can help with streamlining the development of visualizations. So it says for each card, find the correct function to help specifying the filtering. So we have the all, filter, and cross filter. So it says returns all rows of a table, ignoring any filter. That is the all function. When you combine the calculate function with the all at the filter section of the calculate. So change the direction of a specified relationship to both. That's cross filter. Then use to override the cross filtering between two tables. You use to override the cross filtering between two tables. Oh, hold up. Okay, override the cross filter. That's a still cross filter. So you used to filter down the number of rows. I'll go for filter. It runs a table based on a specified filter. That's filter. Used for cleaning filter and performing calculation on all rows. That should be all. Oh, great. We logged that in. So fabulous filtering. There are more functions that can help specifying the filtering, but they are a great start. So let's look at how it is done in Power BI. Okay, it's done in Power BI.
Let's show with an example how count and filtering functions can be used to answer questions and to improve dashboard functionality. This dashboard contains some visuals, slices, and a total amount summary card, which is currently calculated by taking the sum over all amounts in the fact table. As a result, the summary card changes when a slicer or visual is selected. This is a desired result for the visuals, but not for the total amount summary card. To fix this, we can edit the aggregating sum function to filter for all the values, regardless of which slices or visuals are selected. You can do this by wrapping the sum function in a calculate function, followed by filtering all values from the fact table. Now, the total amount card always shows the same result, just as you should expect from a summary card in this case. Next, let's have a look at the different accounts and their associated number of product categories. Each account represents some sort of expense or income belonging to a certain amount in the fact table. To calculate the product category count, you can use the distinct count function. This seems like a strange result, having precisely 8 product categories for each account. This is just the number of unique product categories present in the product category dimension table. The model view reveals why this happens. We want to filter from the DIM account table across the DIM product category table, but this last dimension table only filters from the dimension table into the fact table using this single relationship. In other words, there is no way of filtering the DIM product category table and discounting the correct number of product categories per account, because that info needs to come from the fact table. We could manually change the relationship to both to fix this, and now the report shows the correct number of product categories per account. However, for performance reasons, it is more efficient to leave the relationship to single in the data view and edit the calculation to use a cross-filter function instead. This is achieved by wrapping the distinct count function in a calculate function, combined with a cross-filter function where you set the relationship between the product category dimension and the fact table to both. In this way, we get the same result as before, but it becomes much more transparent which measures make use of the double relationship, and, especially for large tables, this may improve performance. Time to practice.
Okay, let's practice. So once we use the filter or function, it's a calculate function, definitely. So it says filtering using DAX syntax has many benefits. It allows for more control and complex calculation. You can reuse previously saved calculation, and you can override specific filters that are already present on a dashboard. You'll continue working with your previous reports, but now a year slicer has been added. This year slicer has some unwanted effects on your year-over-year chart. Let's fix that. It says open 3.1, which is all. So let me open the file data set from my folder here. So while that is coming up, so from the exercise folder on the desktop, select the a year on the top slider and notice how both the table and the column chart change accordingly. Okay, let's see. Okay, let's look at the measures that we are using here. Uh, okay, I think we are good to go. So select the year select the year on the top select the year on the top slider. So this is top slider. If you select any year, so let me do that. And notice how both the table and the column chart change accordingly. If you select any year, and the table and the column chart are changing accordingly. Okay, let's see. So if you select any year, I think there's no data for 2016 for the column charts. I want to select that. So the instruction now says the year-over-year calculation gets messed up since you need multiple years to calculate a year-over-year change. This is our year-over-year calculation, which is this calculation over here. This calculation was from the previous live stream, that is day 41. We actually came up with this DAX calculation, retail year-over-year percentage. So you can check that out. Let's fix that by creating a new measure in the measures table called retail price year over year all. It should give the retail price year over year through all calendar years. We can use the second term or calculate function to filter an expression through different levels, including an all function for the calendar year. In this second term, could help include all values from different calendar year. So we want to return, so whenever we filter, we want to return this same exact view, which is all the records from here for this uh, bar chart here. So if I select any year, I don't want it to be filtered. We're going to be using the all function to wrap this actual calculation in the calculate function, which is what we did actually here. We want to wrap this actual calculation in a year in a all function. So select this other function here. You can see. So say retail price year over year all. Then we call on the calculate function. We reference the previous this retail price year over year calculation initially. Then we include the all function on the filter to return all the record for that calendar year without any filtering. So if I change this new calculation here, so this is the calculation right now. No, the other one here, which is this here. That what we actually calculated there. So it now says change the formatting to percentage. Edit the column chart so that your newly calculated measure is used. So if I change the formatting of the calculation, which is this, I think this is the percentage already. You have to remove this calculation from this column charts and replace it with our new calculation. So you can see we still have same design, same structure from the column chart, but this time if I select any column, consider my batch column chart rather cease to what? Cease to change, but my table will be filtered. So if I select another here, you can see if you notice the table is getting filtered while this column chart is not getting filtered. That is because we use the all function to return the record for all the calendar year without any filtering. Can see 2014, 2015, 2016. We are returning. So that is the essence of calculate there. We want to return all calculation or all record without any filters affecting any the chart. It can be on the charts, on a visual, on a table. So on any chart you want that to be affected. You now say select the year 2014 using the slider. We're going to select the year 2014. It has been selected. It now says By how much did the year-over-year percentage value change in 2016? For 2016, let's see. That is minus 6.07%. That's it. 6.0, yeah, I think this is it. 6.7. Okay, I think this is one decimal place. If I change the calculation to two decimal place, we should see the is the decimal. See that pretty well now. Because it's 6.67, negative 67.0%, 0.03% rather, which is correct. So great. By overriding the year-over-year calculation with us, so we actually override this actual year-over-year calculation, the initial year-over-year calculation, we override it with what? With the all function here. So it's going to return same value no matter the filter that is applied. So by overriding the year-over-year calculation with all function, you can tweak each part of your report to your likings. Note that you could achieve the same by editing the interactions in the format menu, but creating a DAX function makes it much more transparent, and you can reuse this new calculation easily in the future. Oh, I think that's cool. You can edit the interaction between your charts using the interaction button on the ribbon. But using the DAX function, I think is much more easier and much more flexible than just editing the interaction per chart or per report page, which is kind of not good enough. So let's move on to the next challenge, which is calculating with filter. So when performing analysis for business decisions, it's important to analyze data from different perspectives to find trend issues. In this example, worldwide importers recently introduced items that required refrigeration, that is chilled items. You are asked to look into this further to see if any trend exists among salespersons in the sales of this item. You will do that by looking at what percent of chiller item sales are part of the total for a salesperson. So if you lost any progress, close any open report and load 3.2 filter. So let's load our new report here. Let's load the new report. I'll just load the new report real quick. So you have access to all files under the YouTube description. So do well to download it. So let's open a new report called filter. So what that is coming up, let's see. So create a new page and call it chiller analysis. We're going to create a new report page. I'll call the report page chiller analysis. Still coming up though. Okay, so let's create a new page. So and this is the solution to our last. When we look at it, you can see the solutions are here. So let's get a new page this time around and call the new page chiller analysis. Okay. The instruction now says create a measure called total sales that sum up the fat sales, the total excluding tax from the fat sales table. So let's look at the table real quick. Let's look at the fat sales table. We want to sum up total excluding tax. I think this is this table. We want to sum up audio record from this table in this column, from this column from the fact sales table. Let's go back to our report view here. Let's create a new measure and call the measure total sales, right? Total sales, which is going to be the sum of the excluding, yeah, this actual column from the facts what? From the fact sales table. We know that. Let's hit enter. So if you can drop this in a card visual, if you see the results, you just drop that, I can see it. So the total sales excluding tax is 20 million, about $20 million. Okay, let's get rid of that. Oh, so there's an update to Power BI. So I just recently update my Power BI desktop so you can see some new updates, some new features real quick. That's kind of interesting. Okay, let's move on, by the way. So now create a measure called total sales chiller that calculate total sales, which is our new this is our new calculation. We're going to use it in a new DAX measure. We'll calculate total sales from the fact table only, including the chilled items by using filter. You can use the related function and the dim stock is chiller stock column to check this. So the formula should be structured like this. We're going to have the total sales because it calculates total sales. This actual calculation, you're going to say filter the fact sales table when it's actually related to the fact sales table is related to this dim stock item table. So they have to be related. So this is what we actually want to do. If I go to the fact sales table here, okay, maybe let's go to the model view real quick. If I go to the model view, just not do justice to it. Okay, let's see. So I want to actually filter this total sales function. So I want to filter this fact sales table and the dim stock item table. So these two tables are actually related. I want to filter it. So we're going to create a new. So we want to use this key, the common key within them, which is related to this dim stock item is chiller stock. I want to use the related function. If I go to the table view, that should do more justice to it. Look at the fat sales table here. Oh, let's go to the stock item first. You can see we have the stock item, which is stock item ID here. Which is our stock item ID here. But there's a column called is chiller. Let's look for that. So the chilled item, look at it here. The chilled item is chiller stock. So once an item is chilled, it needs refrigeration, it is going to have the two. So the stock item ID, this stock item ID, which shows for items that are supposed to be chilled, be refrigerated, it's going to be true. So when we go to the fat sales table record, this fat sales table, so you can see the stock item key here, which you can use to relate to the dim stock item table. But instead of using that, we're going to be using the stock item table, which is going to be equals to 2. So let's do that in real time so you can understand better. We're going to create a new function called total sales chiller. So the measure is going to be new measure, going to be total sales chiller. Total sales chiller is going to be equal to the calculate function. Calculate our new measure, this total sales, calculate total sales, comma, but we want to only calculate total sales for no for filter. So we want it to filter so it's going to be filtering the fat sales table. So that's our fat sales table. Going to be filtering the total sales of this fat sales table, but for only records that are related to, so which table come first? Any table can actually come first. Related to the fat sales, let's look at the fat sales table or the other. I need to mention the dim stock item, the column that should be related. So you're going to be using the related function and the dim stock is chiller column to check this calculation. Okay. So it's going to be related the dim stock item. That is the dim stock item. Let me just type is chiller, which is this come on. This stock item here is going to be equals to 2. So we want to filter for items that are equals to 2 in that place. Let's see, I think I'm missing one more column. So this is my calculate function. Then my filter expression is this filter. So within my filter, my related, I use this less. So I'm missing equal. Okay, so that's complete. So if I log that in, let's see. Great, we don't have any error there. So what this total chiller is actually doing is that it is filtering the fast sales table based on the total sales function and only looking at the related column that are in the fat sales, which is this stock item ID that are in the fat sales table, but have its chiller stock item equals to 2. Then it's going to do the calculation for us. So that I think that's one of the easiest way I can actually quickly say that. If I click on this, oh, I'm missing something. Let me see why it wasn't able to load. Let's see the results. So that's not support comparing value type with value text. Oh, something is missing. Like this my okay. I think my data type is the issue. So let's look at the table real quick. It is this challenge with the e-stock. Let's see the data type. That's okay. The data type is true or false. So you can't compare value type with text. So let's change this to text. Okay, so let's see if it's going to work now. Great, you can see. So that column is actually formatted as true or false, which is not bad, but can be giving us error in our calculation. I'm actually referencing it as a text here. It's actually seen it as a text, not as a true or false. So that is what is giving me my challenge. So let's follow the instruction back. The instruction now says, create a measure called percentage total sales chiller. So we're going to be dividing this total sales chiller by the total sales using the divide function. So we're going to create a new measure called percentage total sales chiller. So a new measure called percentage total sales chiller is going to just be equal to the divide function. I'm going to be dividing, say I want to get the percentage, I'm going to be dividing the total sales chiller by the total sales. I think that's so yes. So our numerator is going to be total sales chiller, comma, divided by total sales. This is this one here, total sales. Just log that in, then change it to a percentage. Okay, so let's see our percentage total sales chiller. Okay, you see 0.1%. I think it's already calculating. So you can actually group it by different, aggregate it by different uh categorical data for category point. Let's see. Let's follow the instruction. Now to change the formatting to percentage. Okay. So visualize on a clustered bar chart. Percentage total sales chiller by the preferred name of the employees. Okay, let's now drop this in a cluster bar chart. Let's drop in a cluster bar chart. This is it here. So if you drop in a cluster batch, I want to drop this percentage total sales chiller in it, which is going to be just one. By the employee, let's look at the employee table. By the employee preferred name. Aha, you can see. So you can see that the highest employee here that actually sold more chiller items is this starch. You can see, let's see the percentage of items sold, which is 0.01. Almost the same thing. Okay. In overall, the percentage of total chiller items sold is 0.01, but some employees sold more than the other. So it's probably the percentage is quite minute. Maybe probably hard to quantify, but you can see that at least it's aggregated each employee by the amount of total sales chiller items they actually sold. Let's see the question. The question now says, which employee had the highest percent of total sales in the chiller category? I think that is Taj. Let's log that in. So correct, you got it. It seems that Taj sold the highest relative amount of chiller items. Note that you created this visual without touching a slicer or filter on the dashboard. So relative amount, probably the amount was quite minute in general. Or probably they don't have enough chiller items in stock. So that's why the calculation is quite small there. So let's take our analysis a step further and analyze the count of chiller items sold in different states. Ooh, want to count the chiller items actually sold in different states. That's quite interesting to see. So for this, we'll be analyzing the count of whether an item is a chiller item. We have to actually count whether an item is a chiller item first before you can actually say, okay, let's now once you have the count of those items that are actually chilled items, can now visualize them on a map visual. Okay, so you'll be analyzing the count of whether an item is a chiller item. This is a Boolean expression, and then map this count to a specific region on a map. So if you load any progress, close any open report and load. Let's close this our current reports and just load. Since we have this, we have worked with these reports. Okay, let me just close this and load cost filter. Let me load the report called cost filter. So while that's coming up, let's continue with it. So create a new measure called count of chiller items that counts the number of rows of the dim stock item where dim stock item is chiller, stock column is true. Okay, you can use filter within count rows to count the number of rows that are true for its chiller stock. So we want to count, if we want to use the count rows or function, but in combination with filter. So now as the filter function to filter to only rows that are equals to a certain condition. Okay, that's interesting. Let's see that in action. Oh, okay, these are our, okay, let's continue for me. I'm curious. Let me see. That means my calculation is wrong the other time. Can see it's showing the actual percentage of items sold by each. Let me look at the measure real quick. Uh-oh. Oh, I want to copy my calculate total sales, filter fat sales related dim stock item. Oh, I don't even need to put my store in. Oh, that was my mistake. I need to correct this. Oh, I've seen my mistake now. Even though the column, I don't need to put the column as a text. Oh, hold up a minute. That actually, I changed the data type of, let me look at the column quick from the dim stock item. The column has been formatted as data type 2 or 4, so I don't even need to wrap it in quotes again. Oh, okay, I learned my lesson there. Oh, cancel. I'm still going to use this report, but let me go back to that my filter version. I will just compare the calculation so I can figure out my mistake real quick there. That's quite interesting to see. Okay, we're back here. So actually changing the data type just disrupts the calculation. You can see mine is just showing 0.1 for Akilo. I've been curious, why is it showing 0.1 for all? Let me go back to the dim stock and change the data type back to the initial two of us. Okay, yes. Let's change it back. So I'm going to have this same back here. So my calculation will not show. So I need to go back to, which calculation is this? So I need to change this. So I was saying equal, wrapping in the quotes. But just say equals to 2. Oh, no, not the 2 function. Aha, and this is better. Yeah. So let me now see this. Oh, hold up. This my division. I think this is a division calculation. Yep. So what now see the problem again? Okay, let me compare with the actual this solution part here. Mine is the calculate total sales, filter fast sales, related dim stock item is chiller equals to 2. Exactly. So this is the same thing, but why am I not getting the correct visual? Oh, why am I not getting the correct? What's my mistake over there? Let me see. I'm curious to actually know my mistake. divide total sales chiller by total sales. I got the division correctly, but where am I making it wrong? Getting it wrong though? Where am I getting it wrong? Funny enough, the calculations are all the same thing. Percentage. I'm thinking maybe I didn't format the formatting pretty well. Oh, see my mistake. I didn't format it as a percentage. That is a silly mistake. Now let's see. Aha. So initially, probably say if I formatted the data type, change the data types I did earlier, but I didn't format it the correct way. So I'm still getting same result. So that was my silly mistake there. Look at it, just a tiny mistake. You have to be absolutely sure you are doing everything correctly. So interesting to see that I still work fine, even though I changed the data type, or I didn't actually change the data type there. That's quite funny to see. So that was my mistake initially there. So that was good to know. So say create a new measure called count of chiller items. Okay, let's start with the new measure called count of chiller item, new measure. And let's call that count of chiller items is going to be equals to that counts the number of rows of dim stock item where the dim stock item is chiller, stock is true. You can use filter with count rows. Okay, we're going to say count rows. Count rows. So we want to count which table. I want to count let's hold on. So I need to use the filter now. So I'm not going to say it should count the dim stock table just directly. If I say this count the dim stock table directly like that, it's going to just count all the record there. I'm going to start filter, filter the table. This is the dim stock item here. So my filter expression is going to be where the is chiller item is equal to 2. I say is equal to 2. Just close that. Close that there. That should work fine. We shouldn't have any error there. Oh, great. We didn't have any error there. That's interesting. Now, if I just drop that, so it's actually filtered out. Let me show you what it actually did. This function. If I go to the dim stock table, so I've actually just used the filter function to only count record that are what that are true rather than record that are false. I'm actually counting only these rows of record. Which if you count it here like this, let's see. If you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're going to count 16 rows out of over 1,000 of rows. So we just use a filter function there real quick to count out of 672 rows of data. We only counted, let's drop that in, count of chiller items. That's in 16 record using the what? Using this smart filter function. This filter function with count rows function. That's why it's interesting to see there. Okay, so let's continue following the instruction. So the instruction now says create a cluster column chart to visualize the count of chiller items by state of province. Does this look right? Let's create a clustered column charts. Clustered column charts. Okay, let me just make this a little bit small. Clustered column chart. Let's see. Cluster column chart is it here. So once you create a cluster column chart, so once you count this count of chiller items, this actual calculation that we did here. Let me just make this smaller right here. I could just bring it here so I can have more space for my cluster column charts here. So I was going to grab this cluster column chart calculation. This count of chiller items is just 16. And by what? By state province. If I go to the states city, let's look at the state province. Is it here? Nope. I want you to be on this chart. State province. Ooh, can see by each state, Alaska, California, Hawaii, Nevada, Oregon, and Washington, the record are just the same thing. That definitely this our dim city, or probably we can see that this count of chiller items is coming from the dim stock table. If I go to the model view real quick, you can see where the mistake is coming from. The count of chiller items is our actual calculation, which is this count of chiller items. It's actually coming from the dim stock table, and our province or location or category is coming from the dim city table, and they're not actually related in any way. You can see this table, this dim city is actually related to the fast sales table, and this our dim stock item table is actually related to the fast sales table. So there's no way these two tables are actually related to each other. So that calculation is not going to be correct. It's going to showing us repeated value for all category. So to do that, we could actually say, let me change this filter direction. Since this calculation is coming from this dim stock table, I can change the filter direction. Let me just double click on it and say this direction to what? To both. Let's see if I change it to both. You can see the variation. So it is filtering to here, and it will filter from this fast sales table to this DMCC table. So now let's see our chart real quick. You can see our charts now change accordingly. You can see this is 8, 8, 8, 7, 5, 4, and 1. You see. So that is that. But using cross filtering in the model view is not that great because of some calculative filtering. The report gets slower to load when you're trying to reload the report, and a lot of other uh, defects that comes with using cross filtering direction. So I'm just going to go back to single and change that, and we have our result back as usual. So to do that, I think you can use the cross filter or function to achieve the same result, which is much more better in a DAX, using the DAX language rather. So count of chiller items will always be the same regardless of which state you filter by. That is because there's no relationship from the facts to the what? The dim stock item table, dimension table. So there's no relationship from the facts table to the dim stock item table. There's a relationship there. I think there's no relationship from there's no from the fact to the dim stock item. That relationship there, but it is not getting filtered to the dim city. I think that is why. I think that is why. I think that is why. So now let's use the dim stock or the cross filter function to achieve the same thing. So that is because there's no relationship from the fact table to the dim stock dimension table. Let's fix that by calculating count of chiller item by stock item key with a bidirectional relation using cross filter and the stock item key. Okay, okay. So we need to go back and edit this measure, this count of chiller items, and wrap it in a calculate function. Now let's wrap this in a calculate function. So I'm going to say